big meeting that we have every month for a great presentation by Dale Brown, who's going to cover the design build and provide his views and the experience with APTA. Dale, as you know, has been around a while, 37 plus years. He's a licensed professional engineer. He's done lots of rail and transit experience. So everybody knows Dale, and he'll provide a good coverage of what that is and concept and some of the ideas with regards to it. But the highlight of the show, of course, is from the MTA, and it'll be Bill Gleckler and Allison Ruggiero, who are going to provide design build and cover those aspects as it's practiced or being practiced or proposed to be practiced for the Metropolitan Transit Authority in New York City. And Bill's a principal systems engineer. He's been at it for a long time, 18 plus years in various areas. And Allison's a systems engineer at MTA Construction and Development. She's been in the agency since 2013. And it should be a very good, interesting presentation, because this is the future. This is what's being mandated in certain cities and certain states. So it should be exciting. But please have plenty of questions as we go through this. Dale, do you want to start your presentation?
Yeah, sure. We'll just take off here. So just going to do a very brief overview on sort of the various contract mechanisms that are out there. There's a lot, and I don't want to go into details on all of these. So I'm going to whip through these next sort of 8 slides rather quickly. But we left them in the presentation because, oh, are we recording? I just remembered.
Yeah.
Okay,
yes.
good.
Yes.
That always sounds professional, in the recording. Sorry, edit that out. So, we'll leave these in the presentation, which can be distributed as well as the recording, and they'll both be on the APTA and the INCOSE websites and the RIG as well. So, we'll go through these rather quickly. Came up with this almost tongue-in-cheek concept of a riskometer, riskometer, however you want it. The idea was, you'd sort of go through all of these various contract mechanisms and decide who owns most of the risk. Is it sort of supplier, or is it, agency primarily? And the idea was that you'd quickly, use it as a dashboard. And we may still incorporate this in the APTA systems lifecycle engineering standard that we've been talking about creating and have started creating. So this is just it's out there as a straw man concept. You'll see these come up on some of the slides that I'm going to go through rather quickly, and you'll see the needle swing back and forth a little bit. These slides only kind of talk about the cost risk, the accounts payable risk. So lump sum is pretty, and I'm not going to explain all these. I'm just going to go through them quickly, as I said earlier. So there's the lump sum. There's unit price, which is sort of risk neutral. There's cost plus, which I think probably everybody's heard of, and there's various flavors of cost plus. It probably swings back a little bit risk towards the agency on that one. There's incentives, which can be, depending how they're operated, somewhat neutral in risk. There's guaranteed maximum price, which also can be somewhat neutral in risk. As again, I'm not going to go through and read these, but you can get it all out of the presentation that's online. We'll spend a couple of minutes on this, since this is what everybody's sort of doing now. And I kind of pegged the riskometer over on the agency side, because you'll see in the next slides why. So a lot of contracts out there doing it. There's a lot of prescriptive requirements where you get like 10,000, 20,000 requirements as part of the RFP binders. And, especially if you're going for some sort of a COT solution, you start questioning, well, who's the actual designer? There's a lot of variations on this approach. So we won't get into all of them, but we're going to look at sort of the pluses and minuses. And the biggest minus is that it has a tendency, design bid build has a tendency to really force or sort of incentivize the project to get siloed rather quickly. So you end up with the classic, the architects, the engineers, the various specialty engineers, all in their silos, and they're all looking at their view of the world in their silo. So with that happening, you're going to miss optimizations. And of course, with silos operating like this, you start asking that all important question, well, who's the systems integrator? And we all know the de facto answer to that is it usually defaults to the property owner or the agency. So, with the system, system view missing, you get disparate design solutions, and change control is difficult. We mentioned integration already, and it also restricts innovation to some extent. Now, design build, I swung the riskometer back a little bit more to the left, but it's really intended to replace the traditional, separation of contracts between architecture, design, and construction the way the design bid build does. So it's supposed to be sort of a one point of contact or one point of accountability. Just a caveat here, the Design Build Institute of America is showing on their website a little bit of concern now. There's a lot of ways to execute design build, and it's unfortunately the term is becoming a little bit abused, and it's become a catch-all for a lot of different alternative project delivery methods. So, they're just caution when you see somebody talking about, or you hear somebody talking about design build. Is it really design build? How are they executing it? So ideally with design build, it sort of takes that incentivization away for silo activity. And in theory, everybody will see concurrently the same view, or at least the views will be slices that they can all take a peek at. So there'll be less silo behavior. And it's really becoming popular. As you can see, half the U.S. projects, a lot of money being spent on this approach. 43 states have either, demanded it or widely, permitted it. And there's a nice little quote from the Design Build Institute of America, working under the single contract with the project owner to provide services, single point of authorization. So here's there's some other project delivery mechanism. I won't get into these either, but design DBOM is sort of design build with operate maintain tacked onto the end. There's triple Ps, there's integrated project delivery, which is kind of a takeoff of what manufacturers used to call, and I guess still will call, integrated product delivery teams or project delivery teams, take your pick. They all have features and benefits that could be explored a little bit further. And the question to the folks out in the audience is, and people that are interested in the APTA, contributing to the APTA standard that we've been working on, is this was intended to be a bit of a section, possibly a summary section in that standard. So we wanted to just kind of put that thought out there as make sure that the utility of doing that or including that as a section still makes sense. There's a huge progression towards design build, but I'm sure other project mechanisms are still going to happen. So whether it's worthwhile keeping that in the standard or not is an open question, actually, to everybody. So we can maybe talk about that at the end of the presentation. So you've selected design build. So now what? Here's the key caveats that I'm going to mention, and Allison and Bill will kind of present how the MTA is tackling a lot of these. So process development, Conops is really critical. Requirements management, of course, is always critical. There's some different supplier engagement strategies that you could entertain potentially with design build. But all of those four things above imply a certain level of cultural change, which is not to be minimized. So one of the thoughts going forward is that, you can really help yourself as an agency if you have some tailored process assets. So some tailored internal standards, things like an SEMP or an EMP, configuration management standard for your agency, requirements management standard, that sort of thing. Design standard, of course, most agencies already have sort of a design standard library where they've got reference designs that they can leverage into projects. So that's one consideration, is that you really want to try to tailor the process assets towards design build. You want to be able to reuse these, of course, and one of the intents of actually, doing the APTA Systems Lifecycle Engineering Standard is to help agencies do that, is to do some of this work up front together as a collection of agencies and as a collection of systems engineers from around the world, using that combined experience to come up with hopefully a good combination of a tailored approach for all these standards, which of course include, as you can see from the satisfies links up at the top, all the international standards that are already out there, like obviously 15288, 29148, all the local laws, and the agency goals, not to forget those. There's agency mission statements that need to try to be driving some of this activity. And ideally, the supply chain will conform to the processes and the templates, and potentially, if we get to a mature enough stage, you could use this as a pre-qualification item. Every one of those boxes on that previous diagram bleeds into a whole bunch of work. It's not trivial. Every process, has a policy, and every process should have procedures that relate to it. And the policies, of course, should tie into the agency mission statements. And all of this needs things like training packages, checklists, templates, forms, and finally, tools and tool specs. So all of this is a non-trivial amount of work. Ideally, this is all reusable. So, but it is money. You got to spend money to do it. So the summary is: develop agency standards, get your process asset library tailored for design build. You can require use of those standards once they're developed for all your deliverables. You may want to consider creating an agency supplier surveillance team, or whatever you want to call it. A lot of OEMs have already done this, like General Motors, General Electric. You really need to get under the hood, if you will, of suppliers. And you want to audit them actively, not passively. So do that during pre-qualification. And this is my own personal pet peeve, is that asking for 60 supplier process plans at NTP plus 30 to me is a complete waste of time. And I know I'm going to get some responses that probably sounds heretical, but I've never seen it in my 40 years. I've never seen it provide that much value. Active auditing can provide a lot of value. So that's just a comment. Same thing with CMMI or ISO certifications. You can passively ask for that copy, but the agency really needs to be auditing. And of course, to do that, again, it's money, it's people. And then of course, you're going to see this appear in several slides. Let's start moving away from document centric to data centric if we can. Conops is important. That was one of the next bullets. So you really need to identify and engage stakeholders. You want to capture the executive level business case. You want to model, your as is versus where you want to be concepts. Review the solution space, of course, with the stakeholders, do your alternatives analysis. Out of all that, you should get some stakeholder requirements, turn the needs into good requirements, and then iterate it a little bit and refine it before you hit the marketplace with your Conops, because you really need a good Conops for design build if you're going to get what you want to get out of the design build project. Stakeholder engagement is a big deal. It's actually creating the emotional tie-in between the stakeholder and the project. I prefer to use stakeholder engagement as the key concept when talking about stakeholders, because stakeholder management sounds like you're just sort of manipulating people, which you are to some extent, but really engagement means, what are the stakeholders? Do they feel like they have, emotional ownership of the project? Do they feel like they're part of it? If they don't, you're going to get things, well, you can get unprofessional or unethical behaviors. You can get active or passive saboteurs. You can get diversion, distraction, siloed thinking, factions. So, there's a lot of negativity that can happen if you don't have actively engaged stakeholders. This is blatant advertising, but Bill, Allison, myself, Shamara, Devin, and Dennis put a paper together on Conops development. And there's also a lot of other good information on the PMI website and on the INCOSE website. So, and our intention would be to include some of this pragmatic material into the new APTA standard. Okay, jumping ahead to requirements management. That's pretty critical for design build. And really the key point of this is you really do need a single source of truth for requirements. You should try to use it across all the life cycle, for the entire life cycle, and try to drive it down through your supply chain. Because if they're using sort of disparate databases, you're going to have configuration nightmares. And it really does help with the improved accountability, because accountability through traceability is an excellent approach to all this. Again, getting back to the whole data-driven, data-centric versus document-centric approach to life. And I had mentioned this earlier, but you know, some so-called design build RFPs are providing the supplier with, you know, a bunch of RFP binders containing 10,000, or I've even seen 20,000 requirements for a COT system. So you got to act, at that point, you have to actually be honest and ask yourself, who is the actual designer? It's probably not the frustrated supplier that's reading that RFP. And it kind of conflicts with the whole design build approach and the intent of asking for, especially if the design build approach is asking for a COTS, you know, based proven design. What are you doing with 10,000 requirements? So summary, don't overly constrain the design, write requirements based on the functionality, which comes out of your ConOps. You're probably going to need to do some training or retraining of the writers who are writing the RFPs and the requirements. ISO 29148 is a fantastic resource, and so is the material out of the INCOSE requirements working group. They've got some great publications. You're going to have to teach the folks that are doing these RFPs to be less hands-on in the design, because they're not in theory designing it, but they're guiding the design. So that's, you know, again, trust but verify. You really need the accountability. Single source of truth, can't say that enough. And I also, again, I'm going to keep repeating this, document-centric, transitioning to data-centric is the way of the future. Supplier engagement. So there's alternative methods for selecting the design build prime. You can consider things like technical early engagement, which means you're actively engaging with suppliers on technology or technical discussions. Of course, that all requires staffing and budget. And there are ways to do this without breaking any procurement laws, you know, for fair bidding practices. One way is to just, as part of the REOI, or whatever terminology you use to get an expression of interest, you can send out what your intentions are, and interested parties would have to sign up for that and say, well, we're going to engage in technical early engagement on this project. And we might even do a mini design competition or a mini project, you know, with a certain budget, and each supplier gets paid for that. This is an example down below here that was done for the TOD on the London Underground that I was involved in. And we had 5 suppliers, and we quickly whittled it down to 3 based on, a lot of it was based on the mini project. They actually had to build a version of the TOD and with some minimal functionality. And they got paid to do it. And that way, when we reviewed the scoring, we did sort of a QFD trade-off analysis on, and you can sort of see, I don't know if you can read it, but some of the characteristics like the enclosure design, the speed of the response, you know, the technology they chose, where were they located, you know, could you get to them? What was the cycle time of the R&D, that sort of thing. So we could actually measure or gauge them on measurable things that you will deal with for the next, you know, 8 years if it's a big project, or 5 years. So that's a really nice way to make a data-driven decision on who your prime supplier is going to be, versus, you know, reading their RFP documents and just trying to score it based on what they say on paper. It's much better to measure them, what they actually do. So that's a concept. There's some advantages where you can get higher overall program quality. You know, the candidate who is finally selected is very well familiar with the program. You know them, they know you. The teams either get along or they don't. If they don't, they probably didn't get selected. Reliability growth can start earlier because if you intelligently choose what mini design project you use, that can get you a head start on the project actually. And you can be a lot more objective. And in theory, it can be a little bit cheaper because since the supplier understands what's really going on and you understand the way they do business, there should be an opportunity to minimize some of the buffer costs that get built into bids, you know, the contingency costs that are added. There are some disadvantages, sort of. You do need the supporting roles to execute this, and the infrastructure's got to be flexible enough to execute this as well. So that would require some discussions with procurement and legal. But I'm hoping that we can actually have some of those discussions through APTA and get some conversations going with various agencies from their procurement and their legal teams. This is just an example of what we did for the TOD, a bit of a Gantt chart on how we structured it. And it really did support the pre-qualification of the suppliers. We also scored, what were the risks? Did a bit of a spider diagram here showing, risks to lifecycle cost, supplier risk perception, program risk. So we came up with that doing technical early engagement with a design competition scored considerably less risk overall. Waterfall and basic waterfall, the traditional way we do things, kind of were close. They were even, just even adding technical early engagement without a design competition did reduce the risk quite a bit though. One way to get that technical early engagement, a fairly simple way, but it works, is either through a requirements database, or you can do this, I hate to say it, with an Excel spreadsheet. Shudder the thought, but you can. You ask against every single requirement that you issue, and hopefully it isn't 10,000. You want to know, is this existing functionality or existing performance in the system the supplier is going to provide? And you score it you score the risk, the program risk score, based on how they answer these questions. If it's not released, then it has no maturity. It has a certain score that's associated with that. If it's been out for 5 years or more, it's reasonably mature, that sort of thing. And you can obviously change the scoring to suit your needs and to suit your agency risk management plan. So with that, you can really evaluate on a requirement by requirement basis. And then of course you add them all up and you get a pretty good picture with the proposals that are coming back against your requirements. Okay, well, there's, half the requirements in here. This supplier is coming back and saying extremely high risk. So that's the sort of thing that can help you quite a bit. And then finally, there is some organizational readiness that's required. And I know Bill and Allison are going to talk about that. You need to get that conversation going on. Who is the actual designer? You need to agree how to select the supplier. A Conops is non-trivial. It really does take time to get stakeholder buy-in and what I call patient capital. You need to learn how to write stakeholder requirements and try not to write 10,000 of them. You need support of the enabling processes, requirements management, configuration management, QA, especially CM and QA, they often get left in the dust and they're just assumed to be operating well, and often they aren't, just like often they aren't at the supplier. So without those, the RM process will fail or be suboptimal. Without QA, everything fails because human nature being what it is, people take shortcuts. And when requirements management fails, based on the chaos report over the last 10 years, the project usually fails to some extent. So that's all changed the organization, and use of the stakeholder engagement process is mentioned in the Conops slides earlier. And also the organizational change management presentation that was done in this venue about 2 or 3 months ago, are some resources that you can use to get that organizational readiness there. So summary, design build removes a lot of the design bid build incentive towards silos, but it doesn't eliminate them. You still got to take care of the organization. It's not a panacea. You still need system engineering with, requirements management, V&V, and then you need the supporting things still executing, like configuration management and QA. And with that, I will switch it over to the MTA. And Nicole, did you want to jump in?
Yeah, let me just give a quick introduction to our next couple speakers. First, we have Bill Gleckler. He is a Principal Systems Engineer for the MTA Construction and Development Business Unit. He's also the Transportation Working Group Director at Large and provides mentoring and advice to the INCOSE Transportation Working Group membership. After 18 years in the design and manufacturing of products and systems used in automotive, defense, and aerospace industry, he found himself in this space. He joined MTA New York City Transit in 2003 to work in subway operations. In 2005, he joined the Capital Program Management Department as Deputy Commissioning Officer, eventually transitioning into his current role with systems engineering. And our next speaker after Bill, we'll hear from Allison Ruggiero. She's a systems engineer for MTA Construction and Development and the co-chair of the INCOSE Transportation Working Group. She joined the agency in 2013 after completing her master's in systems engineering from Johns Hopkins. She previously worked as a project manager for New York City Fire Department, managing a portfolio of personnel, accountability, and safety-related communications capital projects. She's originally from New Mexico, and she was a packaging design engineer and project lead at Sandia National Laboratories for 7 years in a previous professional life. So during that time, she worked in organic materials department, designing and building satellite sensor packaging, and later leading the effort to complete the production builds. So I will turn it over to Bill and Allison to take our presentation away.
Thank you, Nicole, for the introductions, and Michael and Dale, thank you for inviting us for this presentation today. I appreciate that. So today we are going to share with you the beginnings of our design build way of documenting our requirements for design build contracts. Certainly, we're not at a we're at a low maturity level. We're going to go on into that in this presentation a little bit right now. So before we get started, we're going through two, I would call, major transformational changes in our organization. One is what you're seeing in the org chart. Recently, over the last 2 years, it's been planned, and it's still being planned, where we're going to be under one construction and development group now. And that includes all of the MTA agencies, where formerly we were 5 independent agencies for capital projects. We're now all under one umbrella. So Long Island Railroad, Metro North, Bridges and Tunnel, and then actually New York City Transit for Department of Buses, as well as subways. So where do we fit? If we can, yeah. So we're within the business unit of the infrastructure, which was formerly, part of the New York City Transit subway system and bus system projects. Where we're in a group called infrastructure, which are working on the very complex systems, I'll call it, for new technology and new bus and subway operational transportation systems. So anything that has new technology or anything that would have software development, we would be applying our requirement documents for those type of contracts. And certainly we do have to align still with the other disciplines. As Dale said in his presentation, we still have this silo approach, where the architects, the mechanicals, the electricals, still have their own spec sections. But we're going to be just talking about the system engineering work of these different design build contracts. Next slide. So a little bit more on the organization. I mean, with the reorganization, the capital program guidance manual is starting to be drafted up. And I just want to share a little bit of that with you. It does align nicely to the system engineering practices. because now there's going to be more of an increased front-end loading for the more complex strategic projects, where it's going to require much clearer scope definition. And it is going to even require us to develop a stakeholder requirements document. For those more complex projects, naturally a Conops would house that stakeholder requirements. But even for other strategic and program adaptive type projects, there could be standalone stakeholder requirements. So it is going to require a lot more stakeholder engagements now, because historically the disciplines would just start going in and designing these systems without having the necessary engagement sometimes. And then they also want to start applying more effective requirement management practices. And then there's that tagline you can see at the bottom directly from the guidance manual with the project definition development, intensely evaluate on the outset of the project. So what they're going to be doing is we're going to be baselining these early documents. Certainly the Conops, we were always doing our Conops. I would say over the last 12 years, we've been doing Conops. But now these are going to be baseline documents for even tracking any changes to either the stakeholder requirements or the actual Conops document itself. We haven't had formal configuration management, processes before. Well, we're going to start doing that now to support this new organization and the way we're going to be executing on design build. The second major bullet, the executive management, after reviewing all of the different disciplines requirements, they saw that system engineering had a style that they wanted to start now standardizing across the organization. So they've asked us to start now expanding out even how we do requirement management on all capital projects, and also to start developing the requirement management guideline for the organization. So we can start moving away from what was historically prescriptive requirements with design, bid, build projects, now moving to more function performance-based type requirements. The other major change, which I want to bring out now, is New York State legislation in June of 2019 passed the requirement for any capital projects for state agencies over the value of $25 million to be processed through this design build procurement process. Now for our agency, at least for New York City Transit, we historically had approximately 90% was going out for design bid build, and only 10% was going out for design build. And that percentage was probably even more 95.5. With design build, that's going to flip. So we're going to be doing 90% design build now, and less than 10% will be design bid build. Next slide. So some more on the organization readiness at the MTA. Again, moving from prescriptive to function and performance-based requirements. For system engineering, this was, we were doing this already. We had function-based, we had performance, and we had non-functional requirements for those complex projects. But this is a move that we got to move the whole organization to more of these function performance-based requirements. And more recently, over the last 4 or 5 months, our system engineering team has been asked, as the other disciplines are developing their own PRDC documents. And what we mean by PRDC, you can see it's development of project requirements and design criteria. So our documents are going to be called PRDCs, or project requirement design criteria. But each discipline still has their own requirements for a project. So whether that's signal engineering, mechanical, architects, they're still going to have their own PRDCs. And our team, system engineering, has been asked to start reviewing that and start to try to get them away from writing these prescriptive requirements and giving them, feedback on how best to write those requirements. And then it's the elimination of our master specs. That was historically the way we would be doing design, bid, build, which were always prescriptive requirements. Next slide. So the big change for system engineering was we had our own master specs that had the lifecycle processes. That was in Division 22. You can see with our 4, lifecycle processes we had. We had 4 of them. We had our overarching system engineering project lifecycle processes, which we're going to go into details in a few moments, how they were from the 15288 and the 12207, but they were a lot more prescriptive in applying some of the earlier industry standards. And then system integration, we had a standalone one for system integration because we had no industry standard for that. And then we had a reliability program master spec as well that we would tailor on a project by project basis, as well as with the human factors. So those 4 master specs combined with all the software lifecycle master specs, where there were 10 plus master specs, we really try to get that more concisely written. And we took a look at the industry, where we were with the industry practices, and they have matured quite a bit with the IEEE standards and other standards, that we were able to now use those standards as our governing way of defining our processes. Next slide. So as we all heard in the past, Dale spoke to it in his presentation. Certainly the 15288, 12207 are your good high-level WAT documents, but there wasn't a lot of how-to documents in the IEEE standards until in the last, I would say, 10 to 15 years, and even more recently in the 5 years with even more standards out there. So today, for our early pre-award development work with the concept development and early design phases, you can see at that bottom tier here, we're using the ANSI AIAA as well as the Federal Highway Handbook, and a light touch even on the IEEE 1362 to perform our concept definition. And then the ISO IEC 29148 is our real good governing document or standard for all levels of requirement engineering, starting with the stakeholder requirements or needs, and then transforming those into stakeholder requirements, and then even to a function base, and even the later life cycle with software requirement specs as well. Next slide. Allison, if you can walk us through this.
Yes, thank you. So after contract award for the design, implementation, integration, and the V&V phases, we align our system engineering and software engineering processes with various industry standards that map back to the system and software lifecycle model standards, IEEE 15288 and 12207. Within the systems engineering PRDC document, we cite specific IEEE standards that provide the how-to guidance for applying the required processes and the details for the various deliverables the design builder will need to create. So you can see a list. We have quite a long list here of all the standards that we cite. Some to point out would be IEEE 1012 for the system, software, and hardware V&V plan and the requirements traceability matrix, IEEE 829 for the master system and software test plan and report, and then other various documents for system and software related deliverables. Next slide. And this is a slide, it discusses our systems engineering specialty processes. So for RAM and human factors, we've tailored, again, IEEE standards for the design builder to apply and the creation of the deliverables that we require. So the overarching industry standard for the reliability, availability, and maintainability processes are the ANSI GEIA 0009 standard and also the DoD RAM guide. The GEIA standard contains more than 70 RAM activities that can be applied on projects. And for our systems engineering PRDC, we instruct the design builder to apply about a dozen of those RAM activities and associated deliverables. And those activities are applied on high complexity projects, projects that contain products that require customization or new, non-COTS type development products. And when there's contract requirements that specify specific operational availability targets that must be satisfied. And for human factors, the standards that we've tailored and we cite are the HFES 100 for the computer workstations and the HFES 200 for the user interfaces. And those are applied when there's a human system interaction that requires software to be developed or for COTS software that has to interface with products and be configured. Next slide. I'll turn it back over to you, Bill.
So what we did was we just walked through that framework of our standards, but there are also gaps in the standards where there's lack of definition within these standards. So where we see there are still gaps, we are filling those gaps with either research that we've done with other federal information systems, technology templates that they've used, where it does also align very nicely with these standards, as well as the tailoring that we end up doing ourselves from those templates. So you can see in the blue, the templates that we have, you know, in our design guidelines also. We feel that the system well, the big one is the system and subsystem architectural design document. Because there's a lack of definition of really doing good architectural design, we felt that for complex systems, we needed to have a very good architectural design document at the beginning of the design phase. So it would be very clear to the agency, okay, all the elements of the system. And we're going to walk it through the appendix to give you an idea of that template. But that was a critical one. And we learned from lessons learned, not having it defined as a good template, that it would be multiple iterations of a submission that would come in from a contractor, where contractors just did not have a good understanding of developing this type of deliverable. So these templates have been recently added over the last few years as we've been applying our lifecycle processes, because they're not new, our lifecycle processes, but we find that we have to put more definition into it because contractors have not been successfully delivering on these deliverables or applying these processes. So that's why we've gotten to the point where now, fortunately, we have industry standards to guide that as well. Next slide. So now what we like to do is just walk you through what our PRDC section 13 does look like. Allison, if you can do that walkthrough.
Yes, I'm going to try and share here. Okay. Can everybody see the document?
Yes.
Okay.
What you see in red is tailoring, though. We're going to be talking about that in a
Sorry.
few moments.
Yes. Let me just get down. So we're going to go into the table of contents here. So this is our table of contents for the systems engineering section, PRDC. Section 13.1 gives some general requirements, but this is also where we note all of the industry standards that the design builder must adhere to. And we also provide a list of all of our documentation and when that documentation and deliverables are supposed to be delivered to us. We're going to go into that real quick. So here's a table that includes all of our documents with links to where we describe those documents further in the document. I can scroll through that real quick. It's a couple pages, documentation. And then get down here, bear with me one moment. So these are our documents. And then we go up here. We have the V model where we show, I can zoom in a little bit, in the V model of when these documents are supposed to be delivered. So these are just the system level documents that we've illustrated in this diagram. So that we have 3 design phases: preliminary, advanced, and final design on the left. And then we have some documents that we are asking for at the end of testing V&V for reports of V&V plan and master test plan and stuff like that. And then other
Allison,
documents
if you
we
can
just reference. Excuse me?
I'm sorry, if you can just pause here after you're done with your explanation.
Sure, you can go ahead.
Okay, yeah, why I want to pause here, Allison, is one of the approaches or one of the big shifts with going with design build over the traditional design bid build, and even for complex systems, we used to go out what we call the RFP procurement process, which was very similar to design build, but there would still be a lot of engagement of our engineering resources working with the contractor during that construction phase. The new organization wants to have as little hands-on involvement and let the contractor do their work, okay? So it does become even more important now to have a well-thought-out, plan-driven approach with well-defined plans and still other deliverables that are coming in through the construction phase, but our involvement is going to be much less as an organization with design build. So good plans, essential. Very clear requirements, essential in order to making sure we get the quality delivery of these projects. Thanks, Allison.
Okay, go back up to the table of contents real quick. So in section 13.2, that's where the systems engineering lifecycle processes and documentation are included. So we have some background information just on if, a concept of operations has been developed for the project. Section 13.2.3 is for the technical processes, related to the IEEE and 15.288 and 12.207 and the SC handbook that we discussed earlier, and also other how-to standards that we presented. We also have a specialty systems engineering process section, and that's for the RAM activities and human factors, where those are discussed at a higher level before we get into more specific requirements below, which Bill will go through. We also have a project support process section that includes information for configuration management and the software quality assurance plan. And then we also have a case tools section for the lifecycle process, and we are using the IBM Doors suite. That's what we specify in our requirements. In section 13.3, similar to the systems engineering technical processes, we have the software engineering lifecycle processes, and also descriptions of those deliverables and documentation. And very similar to the table that I showed you above for the system level deliverables, here's a list of the software specific deliverables for software engineering. And that's about a page and a half or so. Now I'm going to turn it over to Bill to go through the system requirements section. Let me go to that part of the table of contents. Zoom out just a little bit to make it easier.
Okay, great. Thank you, Allison. So what Allison just walked through was the beginning overview sections, as well as the system engineering and software engineering lifecycle processes that the contractor will have to be following, including those deliverables that support the processes. This last section, 13.4, is the actual section for the function-based requirements, including the performance and non-functional. So as you can see in subsection 13.4.6, even though it's a small section right now because it only is a master PRDC we're displaying here, that could be substantially, large of a section, okay? Because you're taking the work from the Conops, from all the stakeholder requirements, transforming them into now functions. So we do our functional analysis, which becomes now the basis for our system requirement document, and that's this section here, where it'd be all function-based requirements around performing activities, tasks, or actions that the system needs to perform to satisfy those stakeholder requirements. And then from section 13.4.7 all the way down to 13.4.25, that's the larger category of non-functional. And you can see that we have quite a large section of those. Each of these sections have their own tailoring notes, which we're going to give you some example of that now by going back into the software engineering lifecycle process. We're sharing this section of our PRDC because this is the most complex section to get the tailoring done and to get it right. Because even with these IEEE standards, there has been quite a bit of advancement, I'll say, of these standards of characterizing the level of complexity of a software project. So starting with IEEE 1558, where there are different levels of complexity of software, okay? This then defines the level of deliverables that would be supporting the project. So as you can see, by definition, we have no lower levels of 1 and 2. Our projects are either going to be 3, 4, or 5. Okay. The second criteria for tailoring is with the IEEE standard 829, which looks at the software safety integrity level. Okay. And you could see the 4 definitions for those integrity level. So the user of the PRDC, whether that's my team, which is only a very small team, but because we're rolling this out across the whole program area now of multiple agencies, naturally there will be consultant designers also now having to use our PRDC. They have to get this tailoring right, okay? Because that sets the rigor and the intensity of how much of the life cycle processes have to be applied, including the deliverables. Next section. And the last section we want to walk you through, and Allison's going to do that now for you, is just the appendix, which includes those templates we talked about earlier.
Right. So we have, we have 4 appendices. We have definitions and abbreviations section. We have an appendix for a placeholder to insert the concept of operations if one has been developed for the project. And then we also have the system and software requirements management plan template. And then lastly, the system, I'm sorry, where is it? There you go. The system subsystem architecture design description document template.
Okay. And the one point I want to bring out about the Conops appendix, the Conops is just a reference document. It gives both the supplier and the developer a better understanding, naturally, of the operational needs. And we just put that into our appendix for reference purposes only. But it gives the contractor a better understanding of the need or the context of the system. Okay.
Okay, that's it. Thank you.
All right, Jeff. Well done. Well done. Okay, we have still about 8 minutes for some questions. And let's see. Would anybody like to go first?
I was trying to madly type. I'm not caught up in the responses, but so I'll speak as opposed to typing the response. It's faster. So I'm just reading through some of them. So I answered, the only one I got answered so far was Srini, and yes, suggesting that the Conops should be included as part of the package. I'm hoping that we can drive it even further, that it's part of pre-qualification or a request for expression of interest or whatever terminology you use, to help drive supplier qualification and eventually selection. And like Bill just said in the previous section, it really helps in the understanding, I think, of it for all of the participants, even if they're not selected. And then there was one just above that from Marcel. Yes, absolutely. Work in the same tool, the same computer-aided engineering tool, in this case, requirements management. I'm in the middle of a nightmare right now with a rather large multi-billion-dollar project, and we're not working in the same tool. And oh dear, never again if I can help it.
I'd like to reply to that one, Dale, if I could.
Yeah, please, Bill. Yeah.
Just to share our experience with that, because in the earlier life cycle, we shared our process with, especially with the system requirements, but even with the stakeholder requirements that are in the Conops, we have full life cycle traceability. So we do start that development indoors ourselves. After award for contract, after the contract is awarded, we then transfer our database to the contractor who gets the award. We didn't go into details with that one section that Allison was describing. In our system engineering case tool, it tells them how they have to manage all aspects of the project, not just with the requirement management aspects of it, but configuration management. So we have full lifecycle traceability. At any time a change was to be introduced, we can do very thorough impact analysis, having that full lifecycle traceability all the way back to a stakeholder requirement and need.
Thanks, Bill. And And bless you
Very
for
good.
doing that.
I'll just add to that. I think these tools aren't trivial. And an organization, if they're going to have control over their information, having the tool and having some control over that, over a single database, even all the documents you're talking about and the ones you're putting templates on, if there's not a tool to manage that and use a central bit of information to create these documents and spit them out at the right time and do the configuration management, you'll need an army of people to do it the old document way. And there's some things to think about.
That's right, Mike. And that goes back to Mike's, Dale's presentation, get away from this document centric. Our organization being so huge, we have been historically document centric. So even with that capital program guidance manual, where they want to start standardizing on requirement management using these type of tools, it's sending the message to me that we're moving away from documents. The rest of the organization doesn't know it yet, but we're going to be moving to a digital world here.
Yeah, right. Yeah, right on. Yeah. Let's see. We got a couple. Oh, a message from Nicole. Everybody check the link there. There's the upcoming conferences for APTA, and Mike had just reminded me this morning that we've got some INCOSE stuff happening. We've got I guess it will be virtual. I think it's virtual. It's not a hybrid, is it, Mike?
No, it is a virtual event in Hawaii. Yeah. Aloha,
Yeah.
So it's, bring your drink and do all that, but it's get in the Hawaiian mood. You might even show up with a Hawaiian shirt.
There you go.
That's how it is.
And I don't know if Nicole, did you want to just quickly before we get on to the rest of the questions? We got a few minutes left, but and there's a question from Marcel that I'd like to get on the table here too. But if you wanted to talk about APTA events.
Yeah, I just want to give a really quick update on some of our conferences and meetings that are coming up. Excuse me. We have our Rail Conference June 6th through 9th, and that will be a virtual event. If you haven't heard yet, our Transform, our kind of annual meeting, Transform and Expo, has been rescheduled yet again to November 7th through 10, and it will now be taking place in Orlando, Florida. It was originally scheduled for Philadelphia and then Anaheim and then rescheduled in Anaheim, and now it's going to take place in Orlando, Florida. Again, the dates are November 7th through 10. And then on October 3 through 6 in Philadelphia, we're going to have a number of co-located workshops and conferences, including APTA Tech, which for those of you who might not know, APTA Tech is the premier technology focused conference that APTA puts on every year. And the APTA Research and Technology Committee and the APTA Fair Collection Systems Committee are the two primary committees that plan and execute that conference. And so that is going to be one of the co-located meetings, October 3 through 6 in Philadelphia at the Marriott downtown. The others are going to include Sustainability and Multimodal Workshop and the Marketing and Communications Workshop, and a few other safety related seminars are also going to be kind of co-located during that time. So we have the APTA Tech call for abstracts is open currently, and abstracts are due back by June 4th. With decision notifications will come out at the end of June. So we will be working once we receive abstract submissions to put together the APTA Tech program. And typically the subcommittees, including this subcommittee, always contribute in meaningful ways to the APTA Tech program. So we're looking forward certainly to working with Dale and Bridget and others, but we would love to hear your ideas. If you have something that you would be interested in submitting an abstract for, we would encourage you to do so. So I'll include a link to that abstract submission portal in the chat as well. And that's, I think, pretty much it for me today.
Hey, thanks, Nicole. And then we got just a couple of minutes, I think, for Marcel. Did you want to kind of elaborate on your question a bit?
Which one do you mean, Dale?
I'm just reading it now, actually.
Well, it sounds like you also have a lot of experience in the design build contracting means in the Netherlands. Well, some of your insights might be very, very helpful.
Yeah, it's probably a simpler way. Yeah.
Well, one of my first comments is about the that we are tending to integrated contracts, and integrated can be in two ways, which is a horizontal shift and a very vertical shift. And the vertical shift is we assign a specific geographical location, a track length, to a specific contractor, and at the end of that track, the other contractor starts. So the interface will be vertical, not horizontal in between systems. Is that also applicable to the United States or to the UK? Or is it also always horizontal between systems?
No, well, I don't know. Actually, I noticed that a perfect candidate to answer that might be Oliver. I'm going to put him on the spot for the high-speed rail project. I think there's some geographical boundaries that are kind of influencing things on that project. I might be wrong though.
Well,
yeah, obviously. I mean, if you have several contracts,
Yeah.
they tie in at some point in time. A good example would be the alignment, right? And so we had the case, without being specific, that one contractor tried to optimize their alignment, only that then all of a sudden it was higher than the other one's alignment.
Oops.
And so, yeah, one of those oopsies, right? Yeah, so you have to obviously integrate, like at least, so obviously between the systems and the third parties, between the right-of-way, between your utilities, between adjacent railroads, and then it depends on how you define integration interface in the first place. You know, the paper I wrote is I focus on technical, but to some people it's everything, right? If two people talk, that's kind of an interface, a verbal interface or communications interface. So one of the things you really have to do is to clarify what exactly is the scope of interface integration management. And then some people, like to not use systems engineering anymore, but systems integration. And all of a sudden, systems integration is really defined as systems engineering, right? And then some people, and so it's really, really important. It's the language that you really clarify expectation management at the beginning. But yes, of course, you have to also do horizontal integration between different systems, whatever disciplines, contractors, you name it. Right?
it's 8:30. Well, it's
I guess
half
we're
past the hour.
We're at
And,
time. Yeah.
But I do want to thank both Dale, yourself, Bill, and Allison. What a great presentation! I hope everybody got a lot out of it. I think it was very informative, but it seems to be the way of the future for probably a lot of agencies to be able to go down this path and to do it effectively. So it might be something that's a continuing theme that we bring up if that's the organizational change that's coming about for APTA that's relevant. We could do
Thank you,
more
Michael.
of these type of things.
Yeah, and I look forward to other agencies sharing their practices, because as I communicated, we're only at the infancy level of developing requirements now for a PRDC or for our design build procurements.
And I think
Yeah.
as you told us, Bill, what's driving this, it's the law. It's New York State law,
Yeah.
right?
That's
You
right.
don't have a choice. So you have
Yep.
to. And I think everybody will probably be in that situation in some form.
Yeah. 43 states are already sort of
Hmm.
pushing it, and it may not be law yet in all of them, but you could see it going that way. So
Yeah. What
excellent.
a great, yeah. Hey, thanks a lot. A little clap there. And thanks everyone. We'll
Yeah,
see you again in June.
Bye now.
Yeah?
Thanks.
Okay.
Cheers.
Thank you.
Thank you.
All right.
Thank you.